In this lesson, we're going to look at some polynomial identities. For the first question, we're told that the expression on this left-hand side is equivalent to the expression on the right-hand side, and we're being asked to prove the identity. Now, to prove an identity, the goal is to make the left-hand side and the right-hand side look the same. And we can do that by manipulating the left-hand side or the right-hand side or both. But we're not going to move anything across the equal sign as we do this. I'm going to work on the left-hand side here. First, let's square x squared minus y and see what that looks like. So that'll give us x squared minus y times itself. And we're going to add the x squared y to that. And I don't want to lose it, so I'm going to bring it down here. X squared minus y times itself will give us x to the fourth minus x squared times y minus another x squared times y. So we'll have minus 2 x squareds times y, and then minus y times minus y is plus y squared, and again I'll bring this plus x squared y down. Now we have like terms here. We've got minus 2x squared y plus 1x squared y, so that's going to simplify to x to the fourth minus x squared y plus y squared. At this point, it's a good idea to look back and see where it is we're trying to get to. And we're trying to get to x squared times x squared minus y plus y squared, what we see over here on the right-hand side. To do that, it appears that we need to pull out a greatest common factor of these first two terms. So let's try that and see what it looks like. Now that'll give us x squared times x squared minus y plus y squared. And as you can see, that's the same expression we have here on the right-hand side. X squared times x squared minus y plus y squared. So now we've proven the identity. Here's another kind of question. This one is a multiple choice, and you're being asked which expression is equivalent to x squared minus y quantity squared minus x squared times y. You've got a couple of different ways that you could approach this problem, but I think what we'll do is we'll take this expression here and simplify it and then see where we need to go from there. So x squared minus y squared is going to give us x to the fourth minus 2x squared y plus y squared when we multiply the two binomials, and we'll just bring down our minus x squared y. Let's look for like terms, and we do have those. We have a minus 2x squared y minus 1x squared y. That gives us a minus 3x squared y, and we'll just bring down our x to the fourth and our plus y squared. And then we'll just take a look at our choices and see if anything over here looks like what we've come up with so far. By the process of elimination, we can see that x to the fourth minus 3x squared y, just with these first two terms, that D can't possibly be a correct answer. That's x to the fourth plus x squared y. We can also tell that A can't be a choice because it has an x squared and a y squared, and there's no place in here for an x to the fourth power. So the two choices that are left are going to be B and C, and our answer looks most like B. So let's go ahead and go a step further. If you factor out the greatest common factor in the first two terms, you'll have x squared times x squared minus 3y, and then bring down your plus y squared. And that's going to match answer choice B. Now let's take a look at one more problem that deals with polynomial identities. You are given the equation 1 plus 27 equals 1 plus 3 times 1 minus 3 plus 9. And the question is, which polynomial identity describes the numerical relationship? And you have three answer choices. When you have a multiple choice question, it's always smart to take a look at what your answer choices are before you do anything else. And we've got for A, B, and C, on the left-hand sides of each equation, we've got a 1 and an n cubed. So we've got a 1 plus n cubed, a 1 minus n cubed, and a 1 plus n cubed. So that kind of gives us a hint of where we need to begin. I want to copy this equation from the question down here in our workspace. We have a 1 and an n cubed. Notice here that 27 could be written as 3 cubed. So this would give us 1 plus 3 cubed on the left-hand side. And that would mean that n equals 3. So here for 27, that would be n cubed. And for 1 plus 3, the 3 would be an n. And for the 1 minus 3 plus 9, we would have an n for the 3 and an n squared for the 9. So let's rewrite it inserting the n's and see what this looks like. We're going to have 1 plus n cubed equals parenthesis 1 plus n, and then another parenthesis 1 minus n plus n squared. Now let's take a look and see if any of our answer choices match what we've come up with so far. Answer choice A has all of the correct terms and all of the correct signs. 1 plus n cubed equals 1 plus n times 1 minus n plus n squared. So our answer is going to be A. Now you know a bit more about polynomial identities. See you next time.